this one is my beef with the whole concept of, oh, well, we know that, hidden variables have been disproven because of Bell's theorem. Because when I say something like, quantum mechanics isn't, right. I don't know. I made a video and I was talking about it, and someone brought up Bell's theorem proving no hidden variables, and I was like, what does that mean exactly? Like, what are these hidden variables that we disproved existing? And so basically, these hidden variables are things that are variables that are in the system when two particles are getting, entangled, right? And so Bell's theorem basically disproved that there's no hidden, like, O plus C or whatever, I guess, on, this particle and this particle that, affects the outcome, right, of it being up or down, right? Instead, we end up with a result that it leans more towards quantum, and quantum, to my understanding, is more random than anything. And so I don't really like this because Bell's theorem, in my opinion, does not prove or disprove anything. Because it assumes that these experiments take place in an idealized perfect vacuum void of everything, including vacuum energy. And that's not even realistic. That's not possible. That's not a thing. That exists nowhere. So you proved that these initial conditions don't exist in a vacuum, right? And I'm not saying that these hidden variables exist. Honestly, I don't think they need to exist. I don't think entanglement is what we think it is. I think it's a lot less complex than it's made out to be. It's not this spooky action at a distance that it's been, kind of made out to seem like. It's like the fact that decoherence is a thing kind of proves that it's really not that mystical at all. In fact, it seems very normal, and I don't know why. I don't even know why it's really treated as such a weird thing. It really, I don't know, it doesn't really make sense to me. But basically, this experiment, this thought experiment, this mathematical proof is flawed because it is assuming that there is no external influences on this system, is what I'm trying to get at, right? So you're saying two particles, right, or two photons are made and they become entangled and they fly off in two different directions, and you measure one as up, the other one must be down, and there's no way to actually predict this beforehand because hidden variables don't exist. There's nothing inside these particles in their initial states that would, decide this. And here's the thing that I think is flawed in the logic is that you're assuming that as these particles fly away, right, we know that if they interact with other particles, decoherence starts to take place and they no longer become entangled and it becomes, white noise or whatever. And so you're assuming that nothing is interacting with these particles in the time that it takes for them to move, right? As they move apart, you're assuming that absolutely nothing has impacted these particles. Because if anything impacts these particles, decoherence has already started, right? And so you're assuming a perfect vacuum void of everything. Not just void of mass, not just void of matter, but even vacuum energy. Because we know vacuum energy fluctuates, right? And so if vacuum energy is fluctuating, wouldn't it also stand to reason that this fluctuation could impact these photons? And if these photons could randomly be impacted by random fluctuations in vacuum energy, doesn't that mean that they have effectively instantaneous decoherence? And so their predictability is immediately not going to line up with what you're saying just based off of that alone. You don't need quantum entanglement and your randomness calculations, whatever, in there to prove that, hey, they don't always perfectly line up anymore, right? And so pretty much what I'm saying is that the initial conditions could be there, but it falls away with, with randomness, with probability, the potential for them to be impacted by basically vacuum energy or any other random interaction that maybe we're not even aware of, right? Because we're assuming we know everything and we don't. So, we're assuming nothing is impacting these particles, and that is just flawed reasoning. And so Bell's theorem does not prove or disprove anything. It's an idealized thought process and mathematical proof that has no real world application. It actually doesn't mean anything because it's not real, because it's not accurate. It's not using, you're ignoring data, you're ignoring reality for this mathematical proof. And therefore it's useless because you can't apply it. It's not applicable. It's not applicable. And that's why when we do experiments, it still doesn't line up perfectly with quantum predictions because, even though it's within the error bars of, reason or whatever, it still doesn't line up with predictions because it's not applicable, because it doesn't work, because it's not real. I don't agree with that. I don't think that it's purely random and that there's no cause of this, entanglement. There's no cause of which one is up and down. I don't believe that. And the reason why I don't believe that is because if that's the case and everything's just random, up, down, right? And we're just making up random things as we go, we would not end up with we wouldn't end up with a structure, because at any given moment that structure would change, right? And I don't like the idea that everything is just random and there's no cause to anything, right? Because the result is we have a relative outline of what, we expect it to be, and it stays inside of that, within error bars prediction range, right? And I don't think that random results, if the results were random, that would be the case. Maybe I just really don't understand that, but I really don't think that it can be random. I really don't think that it can be purely random. There's a probability, there's uncertainty in the outcome because, like I said, fluctuations can happen where basically it decoheres at different rates, right? And, the properties of the particles change, right? But I do not think that it can just be truly random. I don't think that could work. I don't think you could build anything off of that, right? If you had a random generator, right? And you lived your life off of yes or no, right? If every time you had to make a decision, you asked your brain yes or no, and then it just spun the wheel, and if it landed on yes, then, it did it, right? Because every time you thought should I stab myself? It could land on yes, right? And so you would have to be, the probability that randomness is running everything and we have an ordered world that we live in, right? Is just astronomically unlikely. And Occam Razor says that the more simple solution is more likely, right? And the more likely option is that instead of it just being purely random that we ended up with this ordered structure that everything's built on, or everything has a cause, right? And everything having a cause creates this structure, right? And there's an underlying behavior that everything follows, and that is entropy, basically. And following the behavior of entropy builds everything. We don't have this random number generator running everything. You know, there's uncertainty because we don't have all the information, but that is not because there's not information there. It's just that we don't have it, right? That's uncertainty to us. The universe is not living in uncertainty, right? Every moment, the actions that take place are certain. They're certain because it's path of least action, because it's increasing entropy. Whereas in this quantum randomness thing, it's I refuse to believe that anything could be built off of a and last for any decent period of time. I refuse to believe that, because the probability of that skyrockets to infinities beyond infinities so quickly, for it to have lasted not only for this long, 5 seconds, but for billions of years. Yeah, get the frick out of here. You're insane. You're insane. If you think that randomness has been functioning and just we've been landing on heads for billions of years straight, no, we're not. No, we're not. And I feel like maybe I'm misunderstanding, but that's what quantum is saying. Everything's random and it just kind of happens, and we've just kind of happened to get here. And yes, we have just kind of happened to get here, but it's from cause and effect, not a whim, yes or no decision. In a way, yes, but also definitely not, right? And as such, going back to it, entanglement arises between particles because one particle absorbs energy and the other is expelling energy at any given time, and for them to interact, one must assume each role. This results in them being entangled and maintaining opposite spins until something else interacts with them to shift their cycle length. The reason for this is because in every interaction, something either has, every interaction has a slight deviation between it. And because of that, one is always going to assume the role, like when two particles interact, right? Say that they, two stars, come close to each other and they're orbiting, right? And they go, oh, now we're orbiting, right? At some point, right, one of those stars is feeding the other star, right? One is losing energy, one is gaining it, right? They don't just kind of sit there and spin around each other and have no impact on each other, right? That doesn't happen, right? We don't see stars that just kind of chill next to each other and do nothing. One is always taking the energy from the other one, right? Am I wrong about that? Do we have stars that just kind of vibe out and don't do anything? I don't think so. But maybe I have no idea, right? I don't study astrology like that. I'm not like that, right? But I doubt it. I extremely doubt it because it wouldn't make any sense, because why would they do that, right? One is always impacted by the other more, right? And this, one taking energy and one giving it is something that has to happen, right, for the interaction to take place. Because if that doesn't happen, then they don't interact. Then nothing happens, right? Then they didn't interact. And so if they didn't interact, then they can't get entangled, right? Because they didn't actually interact. And so when they do interact, one has to assume each role. And so after the interaction, after this, basically collision of sorts has taken place, one of them is going to have to come out with more energy than the other. Because if not, then they didn't interact. Because then nothing happened, right? Nothing happened then. And you could easily have just said that they never actually interacted in the first place. So in order for an interaction to take place, energy must be given and energy must be taken, right? And because of that, they're entangled. Because now this one has energy and this one gained energy and this one lost energy. And so effectively, this one has excess energy and this one is lacking energy. So what is that? Well, one's spin down and one's spin up, right? It's giving off some energy because it's got money to burn, and this one's in the hole. So it's begging for scraps, right? But if another particle comes along and says, "Hey, buddy, yeah, I'll give you something," right? All of a sudden, now this one is spin up because it's got plenty, right? But that's decoherence. Now we don't look over here and go, "Oh my gosh, they're both up." Oh no, they just decohered. There's no mystical what the heck is going on here scenario. Because as soon as it interacts with another particle, decoherence starts to take place, right? So if as soon as a single interaction interferes, right, then you can no longer assume this predictability. Then it's really not that mystical. It's really not this, "Oh my gosh, how did we know?" We can't predict which particle is going to have what because we don't have the data to predict how that interaction will take place because there's just so much unknown variables basically going on there. And we say, "Oh, well, those variables don't exist." And I seriously doubt that there's not some kind of information we're lacking. Seriously doubt that. So whether it's in the initial interaction and it's just fundamental to the particles themselves as they come in, or whether it's something that happens after the interaction or during the interaction, I don't know. All right? I don't know. But it's not this mystical, this one decides what this one's going to be, as soon as we measure it. No, they decided long ago. They decided at the collision which one was going to be which. And that can change depending on what happens to them, right? And, there's really nothing saying that, this one slowly gives off energy and starts to, this one lost energy and starts to gain it over time. And this one, gained energy and starts to lose it over time. And eventually they kind of do a reversal where this one has excess energy and this one heads into the lack a little bit. That could happen. That could happen too. I don't know. Maybe they're, in a periodic cycle and one is the opposite of each other, but now they're intertwined in their cycles for, maybe ever, or maybe for just a given length of time until their cycles, fall out of phase, basically, because of differences in the properties of the particles. Maybe one has a little bit larger of a mass, at the initial interaction, and so that one's, cycle is going to be different because, its frequency will be different compared to, the smaller mass because it will have, a larger frequency. No. Strike that, reverse it. I don't know. I'm just trying to explain that entanglement's it's not actually anything that crazy. And it doesn't need to be. And so yeah. basically, I don't like the only way that entanglement could be this spooky action at a distance is if decoherence did not exist, but it does exist. So I don't understand. I really don't understand why everyone gets so freaked out about entanglement. I don't know what I'm missing here. I really don't know what I'm missing here, but it's not that, it shouldn't be that weird. Basically, superposition is not real, right? From a probabilistic standpoint, from our perspective, it exists. We don't know if it's up or down until we measure it, right? Until we figure out, until basically we ask. And until we ask the universe, basically, hey, is this up or down? We don't know. For us, it's a superposition, sure. But in the universe knows the answer, right? It tells us the answer when we ask. From a metaphorical standpoint, I'm not saying that like the universe is necessarily, I'm not trying to make this mystical. It's not mystical. It doesn't need to be mystical. It's completely technical, right? But when we measure, effectively, we're asking, hey, what's this spin? And we get a response back, but it's not like it's not a random spit out. Well, it's up now. It was up. And so the superposition is only real to us. There was never actually an up and down. It was up. We just didn't know until we found out, right? And so to us, it seems, whoa, that one was up. That's crazy. But us not having all the information, right? Like, it's like, it's like a magician doing a card trick, right? A magician does a card trick, and the magician knows, right? A good magician, we'll say a good magician, right? They do the card trick and they say, pick your card, any card, right? And they do all this stuff, right? And at the very end, they pull out the card and they go, was this your card, right? And before they show you, you don't know if it's your card or not, right? But they knew. They knew all along it was going to be your card, because that's the whole trick. They know what it's going to be before they show you. But for you're not certain yet. It could be your card or it could be any other card. You don't know, right? But the magician's certain it's your card, right? And then as soon as they show it, oh, whoa, it is your card. That's crazy. It was always going to be your card. That's the whole point, right? And you didn't know. You had to wait to see. But that doesn't mean that that's not, like, that result didn't exist before, right? The card, like, as soon as you pick a card, that's the interaction happening, right? The photons interact, right? And so as soon as you pick a card, that's the photon interaction, the initial entanglement, right? And so your card has now been decided because you're going to measure that photon, right? So you're going to measure that photon. So you chose which one that was your card. You picked that card, right? And so when it comes back out and then they show it to you, was this your card? And you go, oh my gosh, that was my card, right? That whole time when you didn't know where your card went, you didn't know what it was going to be, right? And then he pulls it out, out of his mouth or something, right? Or whatever. They pull it out of their mouth and they go, is this your card? Right? It's super surprising. It's super crazy. But it's really not. Because that's the whole point of the trick. It was already decided. They didn't pull it out of thin air, right? They had your card. They knew it. And I don't know if that's not necessarily a one-to-one analogy, but I think it's a decent, comparison. I I feel like people want to make, like, one of the things, like, I watched, like, PBS Space Time, and one of the most prevailing comments, like, every video I look at, it's just people, like, the top comments are always people saying, I'm so dumb, but I still love watching these videos. Like, the top comments are just people saying, I don't get it. You know, it's like almost people, like, want this badge of honor of, like, this is just so confusing. Like, you know, like, it's like they don't care to actually understand it. They just like listening to the mumbo jumbo. They like it being uncomprehendable to them. They like it being a mystery, right? And I noticed this on all the videos. People feel the need to comment, I don't understand. Like, okay? I don't know. And I feel like there's this culture that's been built around quantum mechanics where people say, if you understand quantum mechanics, no, you don't. What does that even mean? Like, really think about that quote. What does that even mean? Because basically that says, we don't know what the frick we're doing. We're just kind of shooting the shit. You know, for scientists, for people that believe in proof and logic and, like, calculations and stuff, to say, if you think you understand it, no, you don't. Like, what? Okay, well then, why are we teaching it? Like, what? Like, right? Like, if no one understands it, why is it the prevailing theory? Like, what? Anyway. Yeah, I don't know. It just, makes me upset. Anyway, peace out.